Assalamualaikum warahmatullahi wabarakatuh. My name is Luman Hakim. I am from Team 1. My metric number is 13DTK23F1014.
My name is Muhammad Zaim bin Muhyiddin Effendi. My metric number is 13DEP23F1001.
My name is Adan Zafri. My metric number is 13DEP23F1004.
And the lecturer for this presentation is Miss Idura. The course of this presentation is semiconductor devices, and we will be presenting chapter 1 of PN junction. The content for this presentation is PN junction is forward bias and reverse bias. First, what is PN junction? PN junction is a piece of semiconductor that fused together by P-type and N-type material. The plane that separates the two region is called junction. As you can see in this picture, P-type and N-type separated by junction. They have their own region. Okay, next presentation. Slide. In N-type material, electrons readily cross the junction to fill holes in the P-type material. It's a process called diffusion. Typically, only current carrier near the junction participate. Electrons leaving the N material generate positive ion, while other entering the P-type material, the P material, create negative ion. It's just like the picture on the other side over here. Next slide. The depletion region. The combination of electrons, the hole around the junction, create a neutral area, forming a depletion region where current flow stops acting as a small resistance. The interaction of positive and negative ion result in potential difference called the barrier or threshold voltage, which is small, approximately 0.7 volt for germanium and 0.7 volt for silicon semiconductor. Just like the picture. If you confused, you can look at the picture to more understand. That's all for me in this presentation. I will let my friend take over. Bye bye.
Now I will present about bias voltage in semiconductor, and we are focusing on forward bias and reverse bias in a PN junction. First of all, let's start with the forward bias condition. In this state, the positive terminal of the battery is connected to the P-type side and the negative terminal is connected to the N-type side. As you can see in the diagram on the left, this connection causes the depletion region to become smaller. The forward bias reduces the barrier potential, which allows electron and hole to move more freely across the junction. With the depletion region shrinking, the resistance decreases, allowing current to flow through the diode. Now, let's move to the reverse bias condition. Shown in the diagram on the right, here the battery positive terminal is connected to the N-type side, and the negative terminal is connected to the P-type side. This setup caused the depletion region to widen. As a result, the resistance across the junction increased, preventing significant current flow. However, a small current still flow, known as leakage current or bias current, which is caused by minority carriers, but this current is usually negligible unless the reverse voltage is very high. In conclusion, in the forward bias condition, the depletion region narrows, resistance is low, and current flow easily. In reverse bias, the depletion region widens, resistance increase, and only a small leakage current is present. Okay, that's all from me.
Let's talk about the depletion region. In forward bias, the depletion region gets smaller or narrow, allowing current to flow. On the other hand, in reverse bias, the depletion region becomes wider, restricting current. Next, we have the junction resistance. under forward bias. The resistance is low, making it easier for current to pass through. In contrast, reverse bias increase the resistance which block currents. Finally, let's look at current flow. When the PN junction is forward bias, the diode acts like a closed switch, meaning current flows freely. However, in reverse bias, the diode behaves like an open switch and only a tiny leakage current, if any, flows.
That is all from us for this slide. Thank you for watching.